Okay, good afternoon. So, as you know, I don't know if you remember, today I am away, obviously. So, we are still going to receive a lesson. We can't fall behind. Your test is on Thursday, March 9th. And don't forget, I'm doing a homework check tomorrow for all the homework from this week. So, Monday, Tuesday, Wednesday, and Thursday, I am checking your homework tomorrow. So we're just going to continue through the unit. So today's lesson is writing exponents in different bases and solving exponential equations. Okay? So they want us to take each of these numbers that they've given us and use the knowledge we've learned about exponents and write each of these following numbers as a power of 2. So I have to think, okay, how many times do I have to multiply 2 by itself to get 64? I have to multiply 2 by itself 6 times to get 64. So in order to write 64 as a power of 2, I get 2 to the power of 6. Okay? Now here, I know anything to the power of 0 is going to give me 1. That's one of my exponent laws. So 2 to the power of 0 will give me 1. Okay? All of these need to be written with a base of 2. Here, I now have a fraction. This is technically 1 over, and I know 8 can be written as 2 to the power of 3. So this is actually 2 to the power of negative 3, right? If I get rid of the fraction, now it's written with a base 2. Okay? Now here, I have to think, how the heck can this be written as a power of 2? I'm going to play around with my calculator a bunch, and I'm going to find that 2 to the power of 18 is actually this number here, 262,144. Okay, so that one's pretty straightforward. So then we go here, and another way to figure this out, you can play with your calculator and do, the xth root, so kind of how we were doing yesterday, where we were doing, okay, the 5th root of something equals this number. You can say, okay, what's the 10th root of this number? Oh, no, not 2. What's the 11th root? Oh, still not 2. What's the 17th root? Still not 2. What's the 18th root? And then it will give you 18, or it'll give you 2 on the dot, okay? Okay, now they want us to do the same thing, but this time with a base 6. So write each of the following as a power of 6. So 6 to the power of something. So I'm going to go, okay, how many times do I multiply 6 by in order to get 7,776? Okay, so if I do that 5 times, again, you're going to play with your calculator, you should get 6 to the power of 5. Okay, so if you do play with your calculator and you do the 5th root of 7,776, you will get 6. Okay, so if you do, my calculator is a little different, but if you do the 5th root, oh, not like that, the 5th root of 7,776 equals, and you're going to get 6. So I know that 6 to the power of 5 will give me 7,776. 1 over 36, I know 36 is 6 squared. So this, as a base 6, is just 6 to the negative 2. And then here, I'm going to play around with my calculator some more, plug in different values here. So I know I have this, right? And I know that this big number, so 362797056. I know that this number is the number under my radical. I need to figure out what number goes here now to give me a base of 6. So how many times do I multiply 6 by itself to give me this number? It ends up being the 11th root will give me 6. So 6 to the power of 11 will give me all of this number. Okay? So then continuing through, we have simplify each of the following using exponent laws. So this is where it gets a little bit trickier. Okay? So here we have 2 to the power of 9 times 32, all to the power of 4. But I know with exponent laws, I want to simplify what's in my brackets as much as I can. But I can't apply exponent laws because these aren't exponents with the same base. They're not powers with the same base. but I can write 32 as a power of 2. So I'm going to change this, and I have 2 to the power of 9 times, and instead of 32, I'm going to write 32 as 2 to the power of 5. Okay, because 2 to the power of 5 is still 32. So I'm just changing how I'm writing it. Okay? Now that they both have a base 2, I can apply exponent laws, and it's when I multiply powers of the same base, I add their exponents. And I have 2 to the power of 14, which is still, sorry, I forgot there, to the power of 4. And now this is a power of a power, or a nested exponent. So I multiply them, and I'm going to get 2 to the power of 56. Because 14 times 4 will give me 56. Okay? Okay, now moving to the next one, I'm going to look and I see 625 cubed divided by 125 squared. And I want to simplify each using exponent laws. I'm not asking you to evaluate. That would be very straightforward. You could just plug the numerator and denominator into your calculator. That is not what I'm asking. So I'm going to look at these numbers and I'm going to say, well, they have a common base. I can write each of these as a power of 5. So that's what I'm going to do. Instead of 625, I'm going to write it as 5 to the power of 4, because I know that that still equals 625. And that is still being raised to 3, right? Because this is the same thing as writing 625 to the power of 3. Okay, and that's over. And then instead of 125, I'm going to write that as 5 to the power of 3. Because 5 to the power of 3 is the same thing as 125. And that is being squared. Okay, and I know exponent laws. I now have to do something on the numerator because I have a power of a power, or a nested exponent. And I multiply my exponents. So I get 5 to the power of 12 over 5 to the power of 6. And now all that's left to do is subtract my exponents because I have division. And when I divide powers of the same base, I subtract their exponents. So I'm left with 5 to the power of 12 minus 6, which is 6. So 5 to the power of 6. Okay, now here, this one looks a little bit grosser. So again, I always want to simplify what's in the brackets as much as I possibly can before I even deal with that outside exponent. So let's do that. I can't really do anything with these numbers here. I need to write them as the same base. Right away, 49 we're familiar with. We know 49 is a perfect square. So I'm going to go, okay, this equals, and I'm going to do my bigger brackets here. And I know I have a fraction that I'm dealing with. So instead of 49, I'm actually going to write that as 7 squared. And that is being raised to the power of 8. And then instead of 2,401, I'm actually going to write that as 7 to the power of 4. And that is being raised to the power of 3. And then the bottom one here was kind of my indication that my base is 7, because that one's already written with a 7, is 7 to the power of 5. And my whole thing is to the power of negative 2. Okay, now I'm going to simplify even more. So here I have 7 to the power of 2 to the power of 8. So they're power to a power. I multiply them. So I'm going to get 7 to the power of 16 times 7 to the power of 4 to the power of 3. I multiply them, and I'm going to get 7 to the power of 12. And that's still over 7 to the power of 5 to the power of negative 2. Okay? Now I can simplify even further because the top can become 1. When I multiply powers of the same base, I add their exponents. And I'm left with 7 to the power of 28 over 7 to the power of 5, all to the negative 2. Okay, now I'm running out of room, so I'm going to jump here. And I'm left with this now. So I have 7 to the power of 28 over 7 to the power of 5, but that's all raised to the power of a negative exponent. But I can still simplify this in here. I can subtract my exponents because I'm dividing. So I'm actually left with 7 to the power of 28 minus 5, which is going to give me 23 to the negative 2. Now, as I know, this is a power to a power. So I can do 23 times negative 2, and I'm actually going to get 7 to the power of negative 46. But I want to leave my answer as a positive exponent, and as I know, everything has a denominator of 1. So if this has a denominator of 1, in order to make my exponent positive, I have to bump it to the bottom, and I'm left with that this equals 1 over 7 to the power of positive 46. Okay, you can also write it as 1 over 7 to the power of 46. You can write the 46 on the outside. Okay? Now here, I'm probably going to start this one in a second video just because I have a maximum of 15 minutes and I don't want to start this one and then have to stop it. Okay, so this will be the part 1 video and then we'll go to part 2.